Because you listen to this show, I'm going to assume that, like me, you're a person who's fascinated by scientific and philosophical questions. So I wanted to tell you about another show I've discovered recently, the addictive, eye-opening, mind-bending podcast series, The End of the World with Josh Clark. Josh Clark is co-host of the absorbing Stuff You Should Know podcast. And for The End of the World, he dives into existential risks, ways we humans might accidentally wipe ourselves out with the same technology we're developing now in the hope that it will make a bright future for us. For example, how a haphazard physics experiment could end the universe, or why artificial intelligence could take control of the world, or how an artificially mutated virus could escape a lab and create a global pandemic. This is serious stuff for sure, but The End of the World delivers the fascinating science behind existential risks through an immersive experience with a beautiful original score and cinematic sound design that takes you from a spacecraft trying to navigate interstellar space to deep inside your body to the far future where humans have evolved into a post-biological species who live in digital form. The End of the World with Josh Clark is waiting to take you on an adventure. You can find it on Apple Podcasts, the iHeartRadio app, or wherever you get your podcasts. Why not listen to all 10 episodes now and join the conversation on social media with hashtag EOTW Josh Clark. Welcome to Futuremakers, cutting-edge debates on our changing society with leading researchers at the University of Oxford. Our lives are increasingly shaped by automated decision-making algorithms. But do those have inbuilt biases? If so, do we need to tackle these? And what could happen if we don't? With me to discuss this topic are Sandra Wachter, Helena Webb, and Brent Mittelstadt. Welcome to you all, and thank you for coming.
Hi.
Hi.
Hello. The place I wanted to start is at the heart of this discussion. Are some algorithms biased? Are all of them? None of them? And if they are, how are they? Sandra, do you want to kick us off on this one?
Yes, I think that's an excellent question, a very important question. Yes, algorithms are inherently biased, and that makes sense because they learn from biased data. And the data that we feed to those algorithms, they are biased because the world is biased. So it's not surprising that they learn everything that we feed into them and replicate that into the future. And to say that this is not just, theoretical or technical problem, but we also have already real-life experiences that we had to deal with in the past. And just to name, I guess, maybe one or two, recently, I think one and a half years ago, there was an algorithm being used in the criminal justice system in the US, an algorithm that is called Compass, that was used to predict if somebody's going to reoffend. This is being used by judges, basically, to calculate the probability of reoffending. And what was found is that the algorithm was heavily biased towards Black people. So it was attesting a higher probability for Black people to reoffend than for white people. And that's something that happened. And another interesting example would be that we are also moving away from traditional data sources to make, for example, credit decisions. So if somebody should get a loan. So usually you would go into a bank and they would look at your, employment history, your income, stuff like that. And now they are moving away from those traditional data sources and look, for example, at your Facebook profile. They look at your profile, they look at your friends and trying to estimate based on your, social environment if you are a reliable borrower. And this has been used in the real life. And what happened is that those techniques are very racially and gender biased as well. So we can see that those algorithms using vast amounts of data to make very important decisions about us, but they are known to be very biased and discriminatory.
Is there an easy way to avoid this?
No, there's not an easy way to avoid this because you would need to tackle the problems on various ends. You would need to start with data provenance, basically. You would need to know where the data is coming from, where the data is biased, who collected the data, who was paid to collect the data, what was the purpose of that, who is using it, what's the coding community like? Because obviously if the coding community is biased as well or has a specific agenda in mind, then that results can be biased as well. And the coding community is not very diverse either. So obviously their biases are being embedded in the algorithms as well. And because like the coding community is not very diverse yet, that's just a problem that is, getting bigger and bigger. So actually you would need to tackle that on various ends at the same time.
Could we separate out two issues there? Because on the one hand, you were suggesting, I think, that some of the collection of the data might be biased. And presumably that's something that we might be able to avoid in various ways. But a deeper problem is that actually correct data will inherently be biased simply because it's reflecting practice from the past, which may have various causes. Is that right?
Yes, I think we can learn about where data comes from and for what purpose it was collected, but just looking at the data itself would not explain the data, basically. Like you cannot just understand data by looking at it. Very often the biases and the social structure is embedded in there, and actually we would need to understand the social structure of our society in order to understand how the data actually interact with each other. And this is something you cannot really do from a tech perspective. You would actually need, social sciences to give you a better understanding of how specific variables interact with each other.
But suppose somebody was to say to you, look, we're getting complete data about something. Let's suppose that were possible, that the data was absolutely comprehensive, but it turned out that people from a particular social background or racial background or whatever just had been historically and continued to be more likely to default on loans or something. The finance company might say, well, we should treat this objectively. That's a fact. It may be an unfortunate fact, but why shouldn't we be allowed to take that into account in deciding who to lend money to?
That's a good question. I guess, historically speaking, we just as a society decided that we should not make decisions based on specific attributes, and one of them is race. And that's because those groups have been, treated unfairly in the past. So what we're trying to do is correct for this now, right? And giving people an opportunity that otherwise would not have the same opportunities as other people. So we're correcting for that. And I guess this is where the idea is coming from.
On that point, I suppose one of the risks of saying, well, this is objective data, this is complete data, so therefore it's okay to use, it's what we should base our decisions on, is you can very easily start to reinforce the bias. You can create feedback loops where essentially you are taking a bias or some sort of inequality that exists in society and essentially freezing it in code and then deploying that system however far you're going to deploy it. And basically wherever that system is deployed, you've taken what may have been very small bias or very local bias and spread it.
Okay, so we end up with what may be a temporary bias due to some social inequality over the last 10 years or whatever, and we freeze it in our algorithms so that forever after that continues.
Yeah, exactly. Or, at least, of course, until the algorithm is retrained or in some way redesigned or updated. And I think actually that's quite an important component in terms of how you govern these things, how you ensure that you're not just freezing bias in place and spreading it, is that you have to go back, you have to check for it. You have to do that in some sort of systematic way. You can't just say, look, we designed a fair system or we designed an objective system, therefore it will always be fair or it will always be objective.
Computers are getting faster, we can store data really cheaply. Isn't it possible to have algorithms that build into them constant updating? For example, monitoring which loans get repaid quickly and which don't, and updating our records accordingly?
It really depends on what is required to do that sort of updating. If you're, as things stand now, it's going to be down to a developer that needs to choose essentially the conditions that you're looking for, either within the model or the training data or the input data. And if that choice of the conditions that you're looking for is updated over time, then you're always in some way going to need a human in the loop, unless we're talking about algorithms that can essentially reprogram themselves or recode themselves.
I think that one of the issues that exacerbates all the various problems that we've already touched upon is the lack of transparency in algorithms as well. So when we kind of start thinking about, or what could we do to make them more objective or less biased and so on, we have the issue that a lot of the algorithms that are out there making decisions that affect our lives are not clear to us. They're not transparent to us. We don't know what's in them. And that makes it very difficult for us to be able to examine them in any way and hold them to account in any way as well. So I think before we start thinking about solutions to the algorithms in terms of changing them, one thing we would also think about is transparency, and a meaningful kind of transparency that would enable people to actually understand what these algorithms are doing and how they're affecting our lives as well.
So there's different components of transparency, or let's say different types of opacity. I think in this context, perhaps the most important is actually sort of commercial opacity. It's literally not having access to systems or not having a say over how systems should be designed, as opposed to anything sort of inherently opaque or inherently complex. This isn't the machine learning is a black box problem. This is the company doesn't want to tell me about how their machine learning system is designed problem.
Could you just expand on that a little bit? Because as you've said, it's often alleged that machine learning algorithms, by their very nature, cannot be transparent. But this is something quite different from that.
Yeah, it's essentially the difference between, let's say, technical opacity and commercial or political opacity. You can have reasons why you would want to keep information about a system, an algorithm, machine learning model secret. That could be because it's your intellectual property, you have some other sort of commercial interest in it. It could be because doing so would actually expose, say, the people whose data is being processed, could expose them to privacy risks. Could, I suppose, be political reasons why you wouldn't want to do it. And that's different than the technical problem, which is essentially we're using these systems to tackle problems and data sets that are in some way very challenging to human comprehension, that they contain too many variables. It's a decision where you need to take more than 7 to 9 things into account at the same time while you're making that decision. That's sort of roughly the limits of human comprehension. And the systems are learning sort of patterns in these data sets, making these very small linkages or links between records. So it's a case of the scale is very large. It's that the systems are learning in a way that is sort of fundamentally different to how humans learn. And so all these conditions contribute to this perception that machine learning is a black box.
And there's truth in that, right?
Yeah, there's truth in it. I mean, it's not something you can say all machine learning is a black box. There's plenty of work going on to, say, develop more interpretable, simple, linear models that behave similarly to more complex models, behave similarly to a very complex neural network, for example. There's truth in it, but it's not absolutely true. It's not always true.
But I'd like to ask Helena, suppose you get a machine learning system being run by a company which is completely transparent about what it's doing. Here's the algorithm, you could look at the code, here's the training set, we're running this in such and such a way, it's taking into account maybe 1,000 different variables. Sorry, it's far too complicated to explain to you, but there's nothing secret going on here. How's that going to rate on transparency according to you, Helena?
Just on its own, it is transparent, but of course it's not particularly helpful for the vast majority of people. So I could be shown that I'm a social scientist rather than a technical person. I wouldn't understand that. I wouldn't be able to make a judgment on whether that algorithm was biased or not. So we need to think in terms of a kind of a meaningful transparency that can genuinely help people, and that could be in terms of finding ways to make these complex things more straightforward to understand for everybody, or it could be in terms of a kind of having an auditor, sort of an intermediary there, who would be able to sort of make judgments on behalf of large numbers of people. So people who'd be able to inspect the algorithms and to make technical determinations about them, and to be able to advise people on whether they were working with bias, without bias, and so on, whether they could be trusted or not.
Sandra?
Yes, I very much agree. I think there's a general problem of communications between the disciplines. So when, for example, legal scholars talk about explanations or transparency, they mean something completely different than when machine learning people think about transparency and explanations. If you talk to machine learning people that think about making systems more explainable, they actually think about how can I explain why is something happening in that system. Give me a global explanation, give me a local explanation, a decision tree. Why is the system doing something? And they're working on methods to actually understand the internal logic of the code. Whereas from a legal perspective, and probably also from a consumer perspective, that's not particularly the thing that you're interested in, right? You're more interested in some kind of justification of the outcome, which is kind of different. And an explanation could also just be, I'm explaining to you, I'm giving you information why I made a certain decision, But that's probably not the thing that you're actually looking for. You want to have some kind of reassurance that your case has been handled in a fair and accurate and unbiased way. So I think it has a more connotation of justification is what we're actually looking for rather than just information about the process, if that makes sense.
We've got a pretty intractable problem here, have we? Let's suppose you have a company which is acting in good faith. Maybe we've got some expert mediators playing a role who are looking through all the code in the way that Helena was suggesting. They say to the public, yep, we can guarantee that there's no funny business going on here. They're doing exactly what they say. And yet the decision that comes out is completely non-transparent from the point of view of the end user. They just think of it as a black box because they're basically told, well, we've got 1,000 different variables. We could give you a very complicated formula, but it's not going to mean anything to you. Basically, we're just turning the handle on this algorithm and out comes the result. And I'm sorry, you don't get the loan. Is that something we can do anything about?
I guess if you're making the claim that you're using a system that is very intransparent and complex, but has high performance and high accuracy, you would need to, prove that in some way. I think that's something that is very often used in the tech community to say, well, we don't understand those systems, but the trade-off would be way too high. Performance would go down if the system was actually more explainable. And actually, if that's really true, we don't really have full proof of that yet. So I think that's something we shouldn't just take that for granted. And I think there's a lot of work to be done to actually show that those systems are working as intended, that performance is really, really that good as people say it is. And in order to do that, you would actually need to test it for quite some time. And I think at the moment, we don't really have the patience for that. Everything is drilled towards performance and efficiency, and everything that says, you should test your algorithms for quite some time before you deploy them. That's highly criticized. It's also criticized to say we should actually monitor the algorithms once they're being deployed, because just the once check-up thing won't do the trick because the algorithm is changing. How can you make sure that the algorithm is not changing in a biased way? So it has to be a continuous oversight over that kind of thing in order to show that it's okay to use a complex system because the performance is good, but you need to have safeguards in place to ensure that.
So suppose I've got lots of absolutely objective data in the sense that it's matter of fact, these loans were given to these people and these people defaulted on loans, these people paid it back, and so on. And I've got maybe, hundreds of thousands or even millions of bits of data points like this. And I do something like randomly dividing them up into two groups. I run my learning algorithm on one of the groups. I know what their results are. I then predict the results for the other half of the group based on the algorithm that emerges. And lo and behold, it's really good at predicting the people in that other group who defaulted on the loans and those who didn't. It's more accurate than any other method we've tried by an order of magnitude, perhaps. That may or may not be a plausible story, but let's suppose we had that situation. How are you going to react? Are you going to say, well, then that's fine?
It's two things. First, we would need to define what a good outcome would be, right? And that's not really clear yet. Does it mean that everybody should get a loan in an undiscriminated way, or is it that the company doesn't lose money? What is you optimizing for? That's the first question. What is actually a good decision? And the second problem is, even if you do that and you test, you're never going to see the second half, right? If I have an algorithm that, sends 50% of people to prison and lets the other one out in the free, or if, 100 people apply for a loan and I don't give to 50% of those people are never going to see again. I don't know if those people would actually be able to repay the loan. So there's always the cutoff point where I actually don't have any means of controlling if I made the right decisions, because I did not invite that person to the interview for a job interview.
I take your point. So I can imagine a finance company saying, well, look, inevitably we can't know about the people we turn down any more than at a university we can know how the people who didn't get into the university would have performed had we let them in. So inevitably, when you've got any acceptance decision like that, that's going to be an issue. But they might say, when we're assessing whether to make a loan or not, the number one criterion we have is, are they going to be able to pay it back or not? And unless the situation has changed significantly, the best evidence we've got is, the last 5 years, the last 10 years. And here's the best evidence we've got from that. Can they be criticised?
I think you're touching on a really important kind of devil's advocate question, which is that I think we're all agreed that algorithms can be biased because they're made by humans and humans are biased. But is it enough for an algorithm to be just a bit less biased than a human? Like, is that a better outcome? So in the case of the Compass algorithm used in the US system, when those algorithmic risk assessments were first brought in, they were really welcomed, because they were seen as a way to overcome the human bias that was seen in sentencing decisions in the US system. And, there have been various other cases in which, yes, we could say, well, maybe, that the outcomes of this algorithm are biased. But actually, when it's left to human decision-making, those decisions are biased as well. So at some point, we want to ask a question, well, is it enough for an algorithm to be just a little bit less biased than a human being? If we can accept that we'll never get one that's unbiased, would it be okay for it to be just a bit less biased? Or do we expect the algorithm to somehow be more unbiased than a human being is?
Okay, but you might want to distinguish, though, two different cases. I mean, if you go back through legal cases and you use as your training data whether somebody was found guilty or not, then if in fact the judge and the jury were biased, the data you're learning from are going to be biased. That's one problem. But in the case of the loan, it may be that your data are of the form, was the loan repaid or not? And that's not biased data, okay? So the people who made the agreements on whether the loan should be allowed in the first place, that may be biased, but whether they were actually paid back probably isn't. Is it in the same way?
I guess with the loan example, I think it's very important to keep in mind that there is no such thing as neutral data, right? Because, of course, you can say, well, you look at the repayment history and that's fact. But you also would need to look at on what criteria did you base your decision to give the loan in the first place. So you would look, for example, at income or, how many years you have been employed. That seems super neutral. That's fair, right? If you have a lot of money, that's fine. If you have been employed for a very long time, it makes sense that you're going to be able to repay that loan. But what you forget is that who are the people that on average have less income or work less hours would be women, for example. Not because they're unreliable borrowers, but because, for example, they very often, work part-time if they have kids. We have a gender pay gap still going on very prevalently in the workspace. And those, criteria being used to make loan decisions. So to say that this is neutral data is something that is not true and will never be true because we are not neutral in any way.
Right, okay, so that raises a very interesting issue because I can imagine somebody saying, look, from the point of view of the finance company, the only thing I care about is whether the loan's going to be repaid. I understand all you say about women's position in the workplace being different from men's, and let's suppose we're in a situation where that's not changing anytime soon. They might say, well, that's bad luck, but tough. What's it to me? When I'm making the loan, all that matters is whether I'm going to get repaid. Now, you might want to push back against that and say, look, actually, if there's that unfairness, then you as a company should exercise some discretion against the biases within the system, as it were. Is that what you're saying?
Yeah, I guess that's the idea behind that. Because, if you're using machine learning, you're doing two things. You first of all, you're predicting the future based on the past. So you're basically trapped in the past. Like the system will only be accurate if nothing changes. And I really hope that's not the case.
Yeah.
And the second thing is that if you use machine learning, you lose the ability to be the exception to the rule. You're just being judged by people that are similar to you. You're being judged on a certain type of people, like certain class or race or gender or age, and presumed to be like them. And however those people are behaving is the way that your destiny is going to look like. And I think that's something that is very important to keep in mind, because how are you going to give people the opportunity to break with historical patterns if you don't open up doors for them?
And what's the alternative? To rely on human judgment in the traditional way?
I guess like in an ideal situation, it could be something that works in tandem. I am not oblivious to the idea that humans are not the gold standard of decision making. Absolutely not. We do have anti-discrimination laws because humans are not good at making fair and unbiased decisions. That's a fact, right? And humans are very much, they're moody, they are cranky, they can be bribed, you can flirt with them, or charmed, right? You can just, you can manipulate them in various ways. You wouldn't have it that easy with an algorithm. So algorithms would be more consistent than human decision makers, obviously. So you could have them as a recommendation tool, for example, to check for your own bias, right? As long as you don't get overruled by the algorithm, or if it's just an assistive tool, I can think that those two elements, humans and algorithms, could work in tandem and actually make better decisions.
I take the point about sort of algorithms can't be charmed, but they can definitely be tricked.
Sure.
For image classifier, you change a couple of pixels that aren't noticeable to a human, and suddenly a picture of a wolf is classified as a picture of a panda. Yeah. So it's sort of a different problem. I mean, of course, you can trick humans too, but this is deception in a way that's not noticeable to somebody that's looking at how the system operates.
I totally agree. Yes, it's a different kind of deception, I guess, which is why I think we should have like a solution where you have both humans and algorithms rather than completely relying on one, because I also feel like there's an inherent trust thing going on with technology. We trust them inherently. We call them smart technologies, smartphone, artificial intelligence. Like it already has like this is magic or great in the words that we're using for it. So we kind of we don't question their ability to perform anymore. With humans, we're more critical. But we have to think about the blind spots, as you said, with algorithms as well.
I was just thinking as you were saying that, it's true, sort of we have an inherent trust in technology and we think of it as objective and so on. And I was wondering if that would actually undermine this solution of sort of the human and the algorithm working in tandem, because I know I've been part of discussion groups before where we've talked about the importance of, keeping a human in the loop in decision making. But actually in practice, does it tend to happen that where you have a situation and you've got, something giving you like a numerical score about, to predict something, and then you've got the human decision, people will always defer to the kind of the numerical score, and they'll always defer to the technology, because that is the way that we tend to think of it. We tend to think of it as being more objective and definitive and a better decision maker. So even if we set out to try to have that kind of tandem solution, in practice, would it work out that we just defer to the algorithm most often?
I don't know. I guess like in a medical setting, for example, I can think of a situation where you have like expert systems and where a doctor, using an algorithm to detect cancer, for example, and the algorithm would just say, well, look at those cells. I think they're suspicious. And then you still have a human like looking into that and saying, well, that was actually justified. Thank God I wouldn't have caught that. Or not, that's completely nonsensical. It has nothing to do with that, right? If it's just something that doesn't dictate you what to do, I think it can be a very healthy relationship, because it might actually show you patterns that you haven't thought of, or that you didn't see or miss out on. But if you have to still maintain the autonomy to say, well, actually I'm going to overrule this decision now because I know better, because I know the patient for 20 years and I know that's not the case.
Part of the problem we've been discussing is to do with the fact that algorithms, as they stand now, can often be very faulty. And Brent was mentioning you alter a couple of pixels in a picture and it gets classified completely differently. It's reasonable to expect, isn't it, that in 50 years' time that won't still be the case. So algorithms at the moment that are pretty dodgy are going to be hugely improved, because they haven't existed for that long, right?
Well, most of the techniques that we're using in machine learning now are very old. There's certainly developments to them. So let's say that we are able to advance to the point where there are image classifiers that can't be tricked in the way that I described. You can't guarantee that those good methods will actually be used. I mean, we're seeing this problem in the Internet of Things, for example, with security standards, where it's essentially a race to the bottom. So you can't take for granted that even if we do have better methods, that they will actually end up being deployed.
Could you explain a bit more about the issue you've just mentioned with the Internet of Things?
Yeah, essentially that if you have if you have products that are being manufactured to be as cheap as possible, then they may have very low computational power. and as a result, they can't sort of embed some things that you would expect to be embedded on them to guarantee their security. So encryption, for example. If there's not enough sort of computational power on the product to handle that, then you have something that's sort of inherently less secure than it could be if it was designed to be slightly more expensive. So there are competing pressures here. It's not just that the only interest we have is in making sure that models can't be tricked or that the Internet of Things is secure. You have to also deal with sort of market pressures.
Right, but presumably government regulation can provide some answer there, and having certain standards that they have to conform to. I mean, particularly on something like cybersecurity, we understand pretty well, don't we, what the standards are there?
I mean, yeah, it could, but that's assuming the regulation would be passed. That's assuming the regulation would actually be applicable in the places that the products are manufactured or the models are developed. So there's a lot of assumptions that goes into...
Okay, but we have a lot of regulation on things like food standards and fire safety standards and things like that. Yes, Sandra?
We do have that because I feel like you feel the harm if something happens, right? If I get food poisoning, I go to the hospital, I might sue them, stuff like that, right? You want to prevent that. What's the harm of a data breach, right? What's the privacy harm? How does it actually hurt you? And I guess we don't really see it in the same way with having a car accident or having a plane crash where technology fails us and somebody gets injured. I think we are more likely to be okay with data misuse because you don't actually feel it on your body. And I think that's one of the problems that we have. Same with surveillance. Everything you don't really feel, you don't really care so much about is mine.
I take your point, but if you listen to consumer programs on the radio, issues about data security and privacy are coming up on a very regular basis. Cybersecurity is in the news probably most days, one way or another. So isn't it rather likely that the committees of our MPs and so on that are discussing these things are ultimately going to converge on reasonable standards?
We do have regulation that suggests that if you're using personal data, for example, that you have to have privacy, increasing mechanisms in place. So privacy by design and privacy by default. But nobody knows what that means. It's mandating a certain standard that is not defined yet.
Right,
and we don't have that. We don't have any standards. You just have to ensure best efforts, I guess. And that's, as Brent said, that's very much different between what's the best effort for Google as opposed to a startup. Right? What's the level of privacy that you can reasonably expect from the company, depending on scale and how big it is and how much money they have, and the product that you're actually using. Those standards will very much vary, and we don't have a common understanding of what's reasonable here. And the other thing is that I agree, it should be actually more defined, and because if it's not, you need to rely on the ethical conscience of a company to be good. And actually, ethics is not something that makes revenue necessarily. So what's your incentives to go above and beyond the law if you don't have to, if fines are not waiting for you? What's your business incentive to become more ethical?
It seems to me not implausible that in 20 or 30 or 50 or 100 years' time, regulation around things like cybersecurity is going to be just as familiar as food regulation. Food poisoning has been around for hundreds of years. It's not surprising that the law there is relatively clear and mature. AI has only really emerged in a big way on the public sphere in the last 10 years. I don't find it surprising that there we don't have mature standards. Can we just factor out that perhaps temporary problem for the moment? Imagine that we were able to guarantee reasonable standards and conformity to those. Some of the problems we've been discussing would still be there, right? The problems of bias.
Yeah, I mean, I don't see any way to make the world an unbiased place. I don't even know what an unbiased world would look like. It's a bizarre idea.
We need to make the world unbiased, and we'd also need to have a in agreement on what that means as well, because I think we can all of us kind of like pick out examples of when something is biased, but if you asked us to give a definition of what is unbiased or what is fair, we'd actually, around this table, would give you 4 different definitions as well. So it's not just a simple case of sort of, oh, we can just like, make the world even and fair. It's actually deciding what we mean by that in the first place.
I guess it's also not just a technical solution, right? I think it's a bit weird to think that we're just going to tweak the data and tweak the algorithm and all the social and the justice problems are going to go away all the
They're
time,
clearly
right?
not.
Yeah.
Which is insane. I think like what machine learning and those systems do is like they show you, they mirror the world to you, right? They show you what's actually going on in the world. They show you how, women have less opportunities. People from different backgrounds have different or less opportunities. They show you that. But just because you make the algorithm pretty or unbiased doesn't mean that those people are actually going to get better opportunities. So you actually need to start changing the social structure of the world in addition to having algorithms that are less biased.
Yeah, I think one of the potential benefits in terms of fairness or in terms of bias that we haven't considered greatly yet, but that Sandra was just touching upon, was that these systems, one of their benefits is that they're consistently biased. Humans are not always consistently biased, whereas if an algorithm is trained with biased training data, it's going to reflect that bias over time. And of course, it can be tweaked to minimize it, but still, there is a consistency there that doesn't exist in human decision-making. And so, like Sandra said, it can shine a mirror on our own biases. It can help us identify when we have subtle or hidden biases that we weren't aware of. And if we're very honest and proactive, we could actually work to correct those. If these are sort of social biases, then we become more aware of them, and that can only be a good thing. I think one of the great dangers, though, is that information about the bias that exists within a model needs to in some way be public or be transparent. It can't just exist with the company that's operating the algorithm or has developed the algorithm, because again, there will be an interest there in not exposing when your decision making has been faulty in the past.
But there is a problem here with the transparency, isn't there, with regard to these complex machine learning models? How do we even identify what the biases are? Do we need to use other AI systems to identify the biases, or how do we do that?
It may not be quite as complicated as say, explaining how the systems work, because at least some types of bias can be measured or evaluated based solely on the input data or the outputs of the system. So, for example, if I want to determine whether there's been a disparate impact in housing decisions, all I have to do is look at the housing decisions that could presumably be produced by a complex AI model. So for those sorts of problems where you're essentially asking, have I in some way been unfair to a particular group that I'm interested in, or unfair along a particular attribute I'm interested in, then you can do some measurement of the fairness. I'm not saying that you can figure out necessarily where the unfair decision-making came from and therefore correct it, but at the very least you can identify when the problem exists.
So just to clarify there, suppose I'm wondering whether there is a bias between one group and another group. Are you saying I can simply look at the decisions that the algorithm comes up with, and if the proportions of approval or rejection, on a loan or whatever it may be, are significantly different in the two groups, then that shows that there is some bias there?
It shows that there's one type of bias there. And again, you would need to have already observed the characteristic you're interested in. So, for example, if I'm trying to make sure that housing decisions are fair across men and women, I need to know the applicant's gender. So there are limitations on it where, if you don't know those things, then you have to start looking at proxies. But yes, in principle, these things can be done at the output level.
Okay, but to play devil's advocate, the person on the other side will say, okay, it turns out when we look at these housing decisions that men have done better than women or women have done better than men, whichever. But the system had its reasons for that, okay? It was because there must have been systematic differences between them in other ways in terms of their income or how long they'd been in their job or their credit history or whatever it might be. So you can't just tell from those crude statistics whether the system has some objectionable bias.
Yeah, I suppose there is a difference here between bias and sort of fair outcomes. Because with fair outcomes, you are literally just interested in the ratio of decisions across the groups. Whereas bias is more about explaining why you've reached those levels, why they've been distributed in that way.
But by fair there, you mean kind of proportionate.
Yeah, exactly.
Right, okay.
Yeah, I guess like if you think about that, before we actually could test for biases, we would actually first need to agree on a definition of fairness. And
That'll be easy.
And that's super easy. Like, philosophers have been debating about this for centuries, millennia even probably. And as far as I know, you guys haven't come up with anything yet to have like a definite standard of fairness.
We solved it in the first 10 years, and then we've been drinking tea since then.
So like there's still like massive debate of what's fairness. Is it group level fairness, individual level fairness? Is it counterfactual fairness? I don't know how many different definitions there are of fairness. And in addition to that, fairness will mean something very different in different contexts, right? So that will change over time. And what is considered fair today won't be considered fair tomorrow. And what we consider fair today was unfair yesterday. So like to think that we're going to have a static model that will never change and satisfy all our, aspirations of what is fair is highly unrealistic.
Yeah, there's the lawyer speaking, and I'm sure I'm sure you're right. We philosophers will discuss aspects of fairness and different kinds of it, till the cows come home. But you lawyers do actually manage to do a lot of your work with conceptions of fairness and equity and so forth. If you were designing a law to deal with these sorts of things now, what would you do?
Yeah, it's super complicated because in a way, philosophers come up with a problem or steer the path to legislation, at least in my opinion. That's how it should work, right? You see a problem looming at the horizon, and then you get the lawyers in to fix it. And that has happened in very good ways in the past. And one of the good examples that we have anti-discrimination laws, for example, because at some point we decided as a society you should not discriminate based on certain attributes, right? And that's good. But now the technology is changing, and all of a sudden is, discriminating new groups. Because, previously we said, okay, historical evidence showed we have been very awful to certain types of people with certain of background, gender, religion, political beliefs. All of that should not be allowed anymore. Now you have an algorithm now that is reading different patterns and could be starting discriminating against people that don't fall under these categories, right? So it could be I'm starting to discriminate against people who were born on a Tuesday, have red shoes, and like dogs. And this could be a significant, proportion of the society. But this kind of group doesn't really have protection under current law because that's not a class that we have been awful to in the past. So in a way, you would need to adopt the law to catch those people too. And that's something we should work on in the future, I guess.
But I'm wondering how you're going to do this. We've either got to have these various decisions made by humans, or we've got to have them done by computers or by some mixture. And if they're done by humans, they're going to be biased in various ways, right? and very fallible. If they're done by computers, they could in time be less fallible and more consistent, but they are going to have biases one way or another based on past data. So how are you going to solve this? If the biases can be ones that are very deeply hidden and unclear, and what do we do?
Yeah, I guess the difference, the main question that you're asking is what's the lesser evil, the human or the algorithm? And I think that the jury is still out on that. I think the main problem with algorithms is that it's just a scale, and that's a difference in quality of harms that could follow.
So you mean to err is human, but to foul things up completely, you need a computer? Yeah. Right.
Probably. And I guess that's something we shouldn't underestimate. That's just it's faster, it's more consistent, and being more consistent and being horrible is also not a win for us, right? So I guess this is a concern that it just becomes faster, more embedded, and more hidden than it is with humans. But with humans, we very often have some certain decision-making criteria or standards in place already because we know humans can be awful. right? So I don't know, if you apply for a job, you usually have more people on a panel making those decisions. You know, if you're marking an exam, the teacher who taught the course wouldn't be the person that marks the exam. We have like all those things in place. You have to declare conflict of interests, right? So we have those mechanisms because we know humans are very biased in making those decisions. We don't have that for algorithms, even though they might be even more biased and even more hidden bias than humans. And I think this is something we need to work on.
It seems to me, I mean, I'm thinking of examples you've given, which I've often been on appointing committees, I've often been on committees of examiners and so forth. And we do have these procedures to protect against strong individual bias. But that's entirely consistent with there being biases in the group as a whole. And it may even be that those biases are more likely to appear precisely because you've got a larger group. Okay, so I mean, in the past, for example, it may have been that there was a strong bias in favour of men and against women in certain types of panels. Putting more men in there making the judgment wouldn't have helped. It might even have made it worse. Right? Now, somebody might say, well, at least with computers, the very consistency and reproducibility of them means that we can at least subject what they're doing to analysis rather than sweeping it under the carpet.
Yeah, I guess like with the hiring committee, what has changed is like people are being briefed about that now. There's education for the people that are on hiring committees or in HR that have to undergo training to understand like their hidden biases as well. Of course, then the panel itself, if it's just men, that's also obviously a diversity problem. So we started to have a more diverse community making those decisions. Of course, that's not perfect, and you can always like work around it if you want to, but at least we're making it harder for people to be discriminatory. And we're not making it harder for the algorithms to be discriminatory.
But let me push a little bit further because, I agree entirely with what you say, except that that's only in respect of types of bias that we have identified and explicitly guarded against, gender being the most obvious and perhaps race, and a good thing too. But that leaves it entirely possible that there are other kinds of bias which we're not seeing and we can't even test for. Whereas if you have an algorithm doing it, at least you can test for it once you've thought about it.
Yeah, I think not necessarily, because only if you really understand the data and the social structure behind it. Of course, you have protected attributes in your data, and if you change those variables and the outcome is changing, you know that something is biased in the system. But very often you don't know the proxies. There are well-known proxies that we know. We know postcodes are proxies, obviously. We know that kind of stuff. But do you know if red shoes are actually a proxy for something? You don't know that. So unless you actually unravel the social structure behind the data that is representing, you're actually never going to know entirely if you're not making biased decisions with an algorithm.
I agree with everything that Sandra said.
Usually everybody disagrees with the lawyer.
No, I think it's a really good point that, as it stands, we sort of have more mechanisms in place to hold humans accountable. And that's certainly not infallible. And obviously, increasingly we're working towards understanding unconscious bias and how it affects people. But, we have all of these mechanisms to try to understand the ways in which humans might be biased in their decision making. But at the moment, we have less of it or less available in terms of algorithms and how we can hold algorithms accountable for the decisions that have been made, or even retracing them and being able to understand. And that's, I think, where those of us, who feel some kind of caution or concern over the use of algorithms for decision making in daily life, that's sort of where it stems from. Because obviously, these are great innovations and they have the capacity to make decisions at scale and they can produce great advances in our lives. But it's about sort of, at the moment, really not having any mechanisms in place to kind of keep hold of them, to harness them, and to harness them safely. And there is concerns that sort of, sometimes the technology takes off and it starts doing things and then it becomes too late to backtrack. So we talked about, regulation and policy, but that always has a very slow pace and often technology development outstrips that. And then you reach a point where people just kind of put their hands up and say, oh, well, nothing we can do about it. If you look at the kind of the internet, this is a very unregulated space, and people are talking now about, regulations to stop the kinds of content that we see online. But to a large extent, it's very difficult to do because everyone's in the habit of posting all of these things online. And there is a risk, that we'll go the same way, that these things are in place and we reach a point where it's too late to do anything about it, to really stop the harms from taking place.
Just on the point about sort of regulation being too slow to keep pace with technological development, I don't think that's always the case. It is said a lot, but I think there are exceptions to it. The 1995 Data Protection Directive already had restrictions on automated decision making in there, which are effectively restrictions on machine learning. That to me, in 1995 is very forward looking, and also, quite often, the regulations will be defined in such a way where they're very open or they're very broad and open to interpretation. And then you essentially get guidance through, national bodies, supervisory authorities, through the courts. And so it's sort of in this way that, yes, you may not be preventing everything that you would want to, because there's cost to extreme precaution as well. But at the very least, it's not just, we have the law, here's what the law requires, now we have to wait until the next law is actually passed. And I think sort of the iterative aspect of regulation gets lost quite a bit, especially in the debate around artificial intelligence, machine learning.
Could I raise an issue about human bias, which we talked about a bit? And examples occurred to me where there are some very, very systematic human biases, which are cognitive biases. They're not due to biases against a particular group. But when it comes to discussion of probability, most humans are pretty rubbish. Unless we're actually trained to think about probability, most of us do it pretty badly. And increasingly, this can be important in court cases. So I'm thinking, say, with DNA evidence. And various probabilities are quoted. There's only a 1 in a million chance that this person's DNA would match that of the murderer, say, and therefore people think, okay, it's 1,000,000 to 1. They're going to be guilty. And this is notoriously dangerous, and people often don't understand why. Just to give an example, if the police were allowed to trawl through a database of DNA, and there's a 1 in a million chance that any individual's DNA will match that of the murderer, there are going to be 60 people in Britain, thereabouts, who match. And if the police go and then arrest one of those people and say, we're going to put you on trial, and they quote this 1,000,000 to 1 odds, they might very well be found guilty when in fact there's no reason to suppose they're guilty. They were picked out precisely as someone whose DNA matched. Now I can imagine somebody arguing that in a case like that, you're far better with some sort of AI system or some expert system, or with a human perhaps, but who understands the probabilities, rather than relying on a jury of 12 people who are completely inexpert. Now, might not the same kind of thing apply with AI? And, you were talking about appointing committees and things like that, Sandra. Is it not entirely possible that there will be systematic biases that humans have, that we know they have, and that ought to be eliminated from these decisions, and maybe algorithms give us a way around that?
Yeah, I guess for some problems with humans, obviously algorithms might be better, but there are things where they're not better than humans, right? Because as I said, with the hidden biases, they're not much better than humans. And I guess in terms of, performance, it's always a question of, the end doesn't always justify the means. And I guess that's with the DNA example, right? If I sift through all the databases in the world, and my chance of finding something is only 1%, does it actually justify the fact that I'm basically spying on everybody, right? Is that actually worth the cost? Is that worth the privacy invasions? And that's a question that we have to ask ourselves with algorithms altogether. I can use your clicking behavior, your browsing behavior, your mouse tracking movements, in order to predict if you have Alzheimer's, right? This could be beneficial, obviously, it could be, but is it worth the risk of, basically, I don't know, having so much privacy invasive information collected about you? Is that is the trade-off good enough, is what I'm asking. And I think we don't ask that question anymore. Even though in legal terms, that would always be the first question that you ask. As soon as you infringe on one right in order to protect another one, you would need to justify it and say, in this case, it's justified. We don't really do that anymore, but we should think about not just the things that can be gained, but also the things that can be lost.
So this is a symptom of what Helena was talking about how slow legislation is, and we're in danger of just ending up in a situation where de facto lots of stuff is being collected because the tech companies got there before the legislators.
I guess it's different because, traditionally the enemy was the state, right? We have all those human rights that are effectively binding or, regulating state powers. From a legal perspective, usually the state is only allowed to act if there is a law allowing it, whereas everybody that is private is allowed to act unless there is a law that prohibits it. That's just the basis of how our state is governed, because traditionally we felt that the threat comes from the public sector. And I think that might have changed now, and now we're in a space where you can do everything unless it's prohibited. So by default, you're posing more risks to the individual.
So how would you change that?
I think it's, I'm not entirely convinced that we should have a framework that governs AI entirely, because I think that's just going to be high-level principles with no interpretation and no clear guidance of how it's implemented. What I would suggest is, first of all, distinguish between what's research and what's deployment. I think you need less regulation when it comes to research. I think the regulation starts when you start deploying those systems. And the regulation needs to focus not just on the technology, but actually look at the specific sectors where they're being deployed. I think you need to have higher, stricter standards if you're using an algorithm in the criminal justice sector versus using an algorithms for a recommendation system on Netflix. And I think that's how you should approach it. Look at the specific areas of deployment. See if algorithms are actually posing a new risk as opposed to humans. Is it better than a human? Is it worse than a human? Is it as good as a human? And do the laws that we have actually mitigate the novel risks that algorithm brings in a specific sector?
But you'd allow research to go on.
Yeah, research, of course. That's of course, there are ethical boundaries, and obviously that's something that research ethics. Of course, it has to be. But I think that you can be more lenient with research if you don't plan on deploying it right away.
But this might be kicking some of the problems down the road, right? Because the research might end up producing algorithms which are fantastically accurate. You do all your tests on them and so on, but you've still got the issue of not understanding what's going on.
Yeah, it depends on where you deploy it. Again, do I really need to understand how the Netflix algorithm works? Probably not. Do I need to know why I have to go to prison? Probably yes. And I guess this is something where we need to think about. Is it okay to have inscrutable algorithms in high-risk areas? Maybe it's not. Maybe you couldn't say no to that. We have banned technologies in the past because we felt this is unethical, right? We banned human cloning because we felt this is not unethical, even though there could be a market for it potentially, right? So I think having a very open conversation about do we want those systems in specific areas, the jury is still out on that, and we should not just say, well, the technology is here, therefore it will be deployed. We as a society have a say in that.
Right. It can be easy to sort of misinterpret the proposal that highly inscrutable systems should not be used in high-risk areas. I think the point there is that if the system can be proven to be more effective, make more accurate decisions, improve, say, patient outcomes in medicine being a high-risk area, then of course, in principle, you want it to be used. It's not that you're going to ban systems entirely. It's literally just putting pressure on the developers, on industry, to focus much more on explainability or interpretability than they may otherwise. Interpretability quite often is very heavily discounted in terms of the parameters they're being designed for when we're designing these sorts of systems. So I think that's the point of saying we shouldn't be using them. It's, please change the practices around development as opposed to we need to forego this technology entirely.
It's a question of how you govern a country in general. Like, are you more a socialist country that believes that everybody should have the same resources available to them simply because they are part of that society? Or do you want to base it simply on merit, so to say, and more liberalistic approach to that? That's a decision that a country has to take. I get the argument that you say, well, if it makes more sense for me to only give insurance to white men because they're more likely to pay it back, well, that's a business decision, but is it ethical? I don't know, right? Do you want to, tax system? We tax people that make more money more than others. You could also say, well, I earn more money, I worked hard for it, why should I pay more? It's an argument to be made, how do you structure a country? And there is an argument to be made that certain people in our society did not have the same opportunities. It's not always based on merit. Not everybody starts at zero, and if they don't succeed, it's their own fault. It's not. And sometimes it's okay to correct for that with laws and say, yeah, we're just going to give other people an opportunity. And say, okay, we're going to give people that a higher risk insurance, but in turn we're going to, tax people, have higher premiums for people that are more likely to repay the loan, to even things out. That's a question of social justice, if you want to implement it in a society or not.
So this is suggesting actually that the kinds of issues we've been discussing can't even be separated out from big political questions about the structure of society, free market, and I'm seeing a lot of nods here.
Definitely.
It's something that I know when I sometimes talk about these issues with people from a more technical background, that they find it very frustrating. It's like, why can't we just talk about the algorithm and the operation of it? But for someone like me from a social scientist background, this is what's fascinating about it, is actually you have to talk about it, how it exists in the world and the world as it is. And actually we can't really talk about, the biases and the transparency and how you might make algorithms accountable in isolation from the society in which they exist in. And the solutions are going to be found at a societal level in many ways too.
Yeah, and of course, this isn't a new problem. We've been dealing with this for, as long as we've been developing technology in general, I suppose, but in particular information technology, and trying to convince computer scientists to take ethics seriously.
Right. Is the problem here that we haven't even got a set of principles in that way?
The last thing I want to do is recommend more principles be developed for AI ethics. No, I don't think that's the problem. I think it is the distance between the choices made in design and the actual effects of those choices. I think the things that you're worried about, the sort of potential harms, are much more complex in the sense of, if I'm saying do not harm a patient, we are assuming that all patients will see that harm as a negative thing. There is no beneficiary to that harm. Whereas if we're talking about bias, somebody is going to win as a result of that bias, somebody is going to lose as a result of the bias. It's very, oversimplification. So I think it's because we don't have sort of that very clear path. I liked how you put it before, that, you have problems that are inherently confrontational versus ones that are more collaborative, where we're all on the same side working towards the same thing. I think that's really the most important distinction here, is that we can't describe eliminating bias and discrimination in algorithmic systems as this sort of collaborative problem, because somebody's going to benefit from it.
But it can become something like collaborative within society, can we? If more people are encouraged to learn about these things, to think about them, we get more technical people thinking much more about ethics, and ethical people thinking much more about the technical issues, and then we have a big discussion across society.
You would need to convince companies that it's a competitive advantage to be ethical. I think that's the only way you could actually do it. Either you have regulation that forces them, or you convince them and give them incentives to be ethical. It's either of those two things.
Yeah. Okay. Well, you can give them incentives to be seen to be ethical, right?
That's not the same thing, though.
There's a lot of that going around.
Yes.
Ethics washing.
Yeah, and part of the problem, of course, is they're in the business of publicity.
Yeah, ethics is the new black, right?
Yeah. So, I mean, do you have a suggestion to make there?
I guess it has to be. It has to focus on the certain types. I don't think you need to have strict regulation in every sector. Absolutely not. And private autonomy is something both from the individual, from the company set, that has to be maintained, because it's a free market. That's all fine. I think it just becomes really a problem if you have algorithms in in areas that massively affect us or, impact certain types of populations. And again, as Brent said, it doesn't mean you have to bend those systems completely. But I want to have like a higher standard of algorithm being deployed. Then you need to prove to me that the inscrutable algorithm is that much better than a human making those decisions. Otherwise, you shouldn't do it, because especially like predictive policing, criminal justice, these are areas that are already very, very sensitive. Do I really want an algorithm that might exacerbate those problems? No, right? And this is where we need to start looking, I think.
It just some other related thoughts to add to that, and in terms of how this relates to medical ethics. I think a lot of what we're describing as ethics washing, the problem is it's as if the point of ethics is to come up with principles and that's it, or to come up with a code and that's it. And then we pay so little attention to how those principles are actually put into practice, the actual impact that they have on development, on decision making, around how we deploy the systems, what things we're optimizing for, and so forth. In medicine, you don't have that problem so much. It's a doctor is able to say, I took this choice regarding the patient's treatment because I thought that it would do the least harm to them, or most aligned with their interests. So you don't have that sort of problem where there's this lack of evidence of how the principles are actually working. And so I think a couple things that could be done to at least make ethics a more sort of substantive contribution to, let's say, using AI in a good way, would be to require that sort of evidence to be published, or at least be investigated to a greater degree, and also to show what the actual benefit is to individuals that are being subjected to the systems. And that benefit can't be, well, we're providing you a better service. There has to be some actual benefit to the individual.
It's always much easier to identify the problems with something than finding the solutions to it. But I think we are at an important point in these kind of innovations where we need to think about what can we do to bring the ethics into them. And I think there are genuine opportunities to kind of foster a responsible innovation approach to these kind of developments, and have a dialogue with companies and with policymakers to allow innovation to flourish whilst at the same time protecting from harm as far as possible. And a lot of that brings in ethical understandings, different kind of approaches, and as we've been saying, kind of bringing in an kind of inclusive discussion that brings in the viewpoints of different sectors from society as well as a way forward.
Well, thank you all very much. It's been a really interesting discussion. I'd just like to give you all a chance to sort of sum up on a particular point that you think is important. We've got a potential future with algorithms getting better and better, maybe being biased, but not in the way that humans are, and perhaps more consistent and less biased, and maybe open to inspection and so on. But there are clearly some dangers as well as promise. So, Sandra, do you want to lead off?
Yeah, I think the main message for me would be we need to think about how we govern AI and what tools to use. So I think it's important to think about the relationship between ethics and law, and to figure out where ethics has its place and where law has its place. And there's a lot of advantage of having self-regulation and codes of conduct and like ethical approaches, because it's more agile, it's faster. But at the same time, if you don't follow those rules, there's nothing you can do about it. They're not enforceable, they're not legally binding. At the same time, if you have too many hard laws governing everything, you could start stifling innovation, hurting the market economy. And that's also not a good thing. So having those tools available is very good, but thinking very consciously about both advantages and disadvantages and deploying them responsibly.
Brent?
Yeah, I would just recommend that before we deploy highly inscrutable systems, that we make sure that we understand really well what we're giving up in the name of greater accuracy or efficiency or profits or whatever it is that we're trying to achieve by using these systems. Because there's quite a bit of value in being able to engage in a dialogue with a decision maker. And if you don't have a comparable mechanism in place for algorithmic systems, then you're losing out on things like developing your own self-understanding, how you can behave differently, what you can do differently in your life, the actual impact of, say, your behaviors on people's, the actions taken towards you or how people see you. So we need to consider, what is the actual value of being able to engage in dialogue with other people, organizations, and now algorithmic systems that are making decisions about you.
Helena.
I really build on Brent's point, and I think it is important to have this dialogue, and as part of that we need to have a transparency, and in that we need a meaningful transparency so that algorithms can be interpreted by if not everybody, by then key stakeholders who are able to understand them and to hold them to account. So we need to have some kind of accountability mechanisms. It's not simply enough for us to be able to see what the algorithms are doing and where the bias may be. We need to be able to act to redress that bias as well. So we need to think about in what ways we would hold algorithms or the companies that develop them accountable. And would that be through the law, or would it be through other mechanisms? And one final point, a little bit more practical, is that one of the things that we could do moving forward is look to other industries and see what kind of mechanisms they have. So, for instance, in the food industry, we're very familiar with sort of fair trade logos and British Farm Standard logos on the goods that we see. So could we have a system in future where we'd have kind of a kite mark for a trusted algorithm? And so then consumers of different kinds would be able to see that this algorithm has been kind of independently monitored in some way and feel that they were able to trust that algorithm as well.
Right, well, thank you very much. It's been an interesting discussion, very interesting, and I'm sure our listeners will find it so too. Thank you.
Thank you
very much.
Many thanks to Sandra Wachter, Helena Webb and Brent Mittelstadt for what has been another fascinating and thought-provoking discussion in our first series of Futuremakers. And thank you for joining us. If you've got any questions or suggested topics for us, please do get in touch on Twitter @Uni of Oxford, all one word. And if you've enjoyed this episode, we'd be very grateful for a review on the podcast app of your choice. Next time we're here, we'll be discussing the future of the banking sector, so make sure you join us then. I'm Peter Millican, and you've been listening to Futuremakers.